So I just have a couple more problems to do in this section. And what we're going to do first is this one. And it's got a square root in it, so it looks a little bit different. But we're still going to use L'Hopital's rule. I was getting ready to say we couldn't use L'Hopital's rule, but we actually can. So what I'm going to do is I'm going to pick the highest degree on top and the highest degree on the bottom, which in this case I have to keep the square root around it. What happens here then is I'm going to simplify this, and I get negative 3x over the square root of x squared is an x. But when you take the square root of something, you could get plus or minus that value. So since this is going to positive infinity, we're going to just say it's a positive x. So let me say that again. When you take the square root of a number, we could end up with a plus or minus value, but we're going to keep just the positive portion because we're going to the positive infinity. So that means that as it approaches infinity, the answer would be negative 3. Now, if you'll notice, my next slide is the exact same problem. The only thing different is now we're approaching negative infinity. So I'll go about it the same way, where I'll pick the highest degree on the top, and I'll pick the highest degree on the bottom. This time when I simplify, and I take the square root, because I'm talking about going to negative infinity, I'm going to keep the negative x portion of this. Remember, this is actually plus or minus the x, but I'm going to keep the negative portion because I'm going to negative infinity. So when I cancel now, I end up getting a positive 3. So in essence, what I'm telling you on this last problem is that the function negative 3x plus 1 over the square root of x squared plus x has horizontal asymptotes y equals 3 and y equals negative 3. So when we start getting into more of these and finding horizontal asymptotes, I wanted you to know that the square root ones will typically have a positive number and a negative number that goes with it. This last example then, it has a trig function in it. Please don't overcomplicate this. Just think about what it means to approach infinity here. And so what we would really have is we'd have the cosine of, if we're approaching infinity, 1 divided by a really, really big number, which is going to 0. And then I know that the cosine of 0 is actually equal to 1. So I'll have my answer rather quickly.